to continue to discuss about the memory management in operating system. So last class we have talked about the data structure of the process. This is the process that we are dealing with. So actually it's in the memory. So when you see the 0, 1 maps, that means so address. So lower address to higher address. So each process will be allocated to the part of the memory. So from the lower address, it consists of the text where the programming code, in other words, the instruction, set of instruction will be located, and the data include the global variable, something like that. The data has been used in your program, and the heap is the area is the dynamically allocated through the process. And also the stack will be used for, it's a log. It's used for the temporary space, it's log, the data structure. Anyway, so this is a process, and this process can be managed by the PCB. PCB is the process control block that includes the most of the important information about each process. Then the PCB, each process has the one PCB, then the operating system will manage the number of processes using the PCB, not directly access the process itself. That includes the process state. The process state, mostly the 5 different states, new, ready, and from the ready queue, it will be picked by the scheduler or dispatcher. So we will discuss the scheduling algorithm later, details in chapter 5. Then, if that is selected, which means the CPU will access the instruction in the process. That is a running state. However, if the process, there are several ways, different cases to be moved to the other state. For example, if the running process asks I/O input and output, there's nothing you can do. So you need to just wait. So which means we'll move that process to the wait, then another process will be selected, something like that. So that is the running state and wait state. From the wait state, you can wait the response of the I/O devices. Once you got such a response, you can the state, your process will be changing into the ready queue, and which means ready to get the CPU resource. Once it is done, it will be terminated. Today we are going to see the details of how to create the process and how to terminate the process. Then when we create a number of processes, then they need to sometimes work together. In other words, they need to communicate. So we will see how they are communicating. That means inter-process communication, IPC, today. So this slide shows the context switch. We will see a little bit details about the context switch later. Okay. Anyway, the two process elements. So we will copy all the information about the current process when context switches happen. So to the PCB. Similarly, we can bring the PCB information to the register for the next process, like that. And for the scheduler, there are mainly two types of scheduler, long-term scheduler and the short-term scheduler. Long-term scheduler, we will select job by job, task by task, process by process, which is not frequently used because it's very costly. You need to bring all the process information from memory to hard disk drive. It's a swap. It's called a swap out, and also bring the new process swap in, which requires a lot of resource, takes a long time. Nowadays, instead of swap in and out, we use the other way of the memory management. So that is a long-term scheduler, and short-term scheduler is for time sharing of the CPU. So we can use anyway, if we are using single processor, which means we have only one CPU time, but we can run the many processes. How? By slicing the CPU time and changing. So to do that, we should have something process scheduler to select the next process, Okay. So you can see the different the ways of moving from current running state to other IO request time slice expired, and when you create the new process, it will be wait. So we will see details about the local child process and the wait process, and also terminate. Okay. So I think that we discussed context switch. We discussed about that context switch. Okay, process creation. I think that because of running out of time last class, I quickly introduce the process creation part. So I'm going to resume today's class from the process creation. So we have the first process when we turn on our operating system. Okay, usually it's called init or kernel process. This init process, the basic mechanism of the creating process is we copy the process, current process, to the next one, child process. This just clone of that. Then assign the specific task instruction to that. So actually 2 steps. Copy, make the clone, then next, the copy the specific instruction code to the processor. This is called fork and exec. Together is a creating process. So even Windows, Linux, Unix system, they have the same mechanism to create the process, which means eventually it will form something process tree structure. Okay. So that is the creating process. So in case of Unix or Linux, it uses the fork. Fork is system call. Okay, API, system API, to copy the current process and child process. Then exec system code actually bring a new code to that child process. Then will be independent, not independent, separated. Okay, as you can see this slide, during the fork, actually they are sharing. All the data are shared. Okay, so same thing, same as parent during the fork. Then if you send the exec command, then it will be separate. Still, it's governed by parent. In other words, parent is waiting for the response of the child process until end. In other words, terminated. So that is the parent and child process relationship. Okay. So this slide shows the process tree in Linux system. What about the Windows? Windows actually basically same. So we will see such an example of that. So this process shows the fork and exec. It's a current process, okay, parent process. Some execute the fork, the system code, and copy make the clone of the current process, which is the child process, but it's just exactly same code, share the same memory, data, and everything. Then the exec command, who execute that system code, parent process, submit this code, then child process has their own code, is via the process. Then at that time, parent process is waiting for response from the child processor, just as if your parent is waiting until you get back home. Okay? Then, if the child process is done, okay, then the parent process resume their own job. Okay? What if parent process is terminated? So that's the problem, that's the issue, because this child process rely on the parent process. Okay, so we will see the case the parent process is terminated before the child process. This is the example of the C programming. Okay, you can see the several the system code. Sometimes it may be depending on the branch of the Unix system. It's a different name, but mostly you can easily understand the meaning of the semantic of that system code. This is the fork. Okay. Output, return code of the fork. For example, the fork, the system code is process ID. If this, sometimes you cannot create the child process, lack of the permission or lack of the resource, the return code PID is the minus negative code. Then it's an error. Otherwise, if it's zero means it's created, but it's not separated yet. First time, when you check the process ID of your child process, no child process ID. Okay, it's just the zero. Zero means it's okay, it's created. Then you can send the exec command. In this case, exec_lp, the run command line. Okay, so code like the ls command. And there are, depending on the system code, there are different parameters. So you can check from the manual, or you can check with the, some reference site. Okay, otherwise, so that's it. So that is up to only the fork, which means it's just make the clone. This is an example of the C program. And what about the Windows API? Windows API actually basically the same, but they realize most of the case fork plus exec, right? We don't want to just a fork, right? It's just a waste of the resource. Most of case, 99% of case, fork plus exec. Why don't we combine into another the system code? So in terms of Win API, so that is create process. It has 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 the parameter values, so you can check from the reference book for each. Okay, but this one is to create the process with MS Paint, which means you are going to execute the MS Paint, Microsoft Paint, the executable file.
So it opens MS Paint program or?
Yes, it's as a child process. Okay, it's open the MS Paint, kind of double click. If you double click event, okay, actually double click event is this one. Okay. That is the example of the Windows API. So you may get the idea how you can do the one more project. So if you want to do the C, or some of the students already asked me whether you guys can use a Linux or Unix environment, totally fine. Okay, you can use the C program, you can use the C++, or you can use the Java. Right? With the Linux or Unix environment, or if you want to use the Windows API, it's totally fine. Okay, so this is a screenshot of when I list up the whole process. So depending on the operating system, some of the operating system 0. 0 is not actually the init. You can ignore. So it started from 1. It's the init. It's kind of corner, the first process. And this one, that definitely does not have the parent process. And in this example of the operating system, 1 init and page out, you can see the 3. The process are created at the same time. So your operating system actually creates 3. The default process actually, this is not the page out and FS Rush is kind of algorithm to manage the basic algorithm used in the operating system. Then init create the 284, that is a console. Console is actually this one. And 286 is the, I don't know what that is. And 164 is a network daemon. So this process in charge of the network, something like that. And most of the process whose parent ID is 1 are related to the default system process, kind of service. Okay, like that. Sometimes it's hard to see the process tree structure. So you can use some of the operating system provided some command to see such the tree structure. You can easily see one, the child process is this one, the 2 to 9 is under 2 to 7 and so on. In this case, you can see that this command is here. So most the down descendant, the process 18451 is a child of this. Is the C shell program. C shell program actually forked by the SSHD is a secure shell daemon, and also this one is forked by another secured shell and also another secured shell. Okay, then this one is actually forked by created by the init program. You can understand process tree. Also, this is the good way to take a track. You can track when you track the process tree, kind of reverse engineering. When you got the error message of the process. Okay.
So when we say fork, means we are creating a process.
Excuse me, I cannot hear you.
When we are saying fork, then we are saying we are creating a process, right?
Oh yes.
And then what does EXEC mean?
EXEC. I says fork is the copy, just exactly copy. Okay? It shares the code even. It shares the memory data. It shares everything. It's just copied. Then EXEC, using the EXEC code. So for example, I want to execute the notepad. Then you can specify the notepad program for that process. Okay? So then your child process will have own code. Then process for something other. For example, in this case, when you fork, create the child P3A minus A, first you will copy the C shell process for this child process. Exactly C shell. Then using EXEC, you can assign P3 program to this the child process. Then it will work for the P3 command.
This EXEC, does it stand for executable?
Yes, right there. Yes.
That's why it executes.
Yes. So always fork plus EXEC. So why don't we use just a simple one? Then actually combine this one and this. So when you double click the icon, that means internally your operating system create the process or fork plus EXEC for that destination. Bring destination and put in your child process. Okay. This is in case of the Windows. It's somebody make the program to see browse, display the process structure. I will show the example of first. This is the Linux, the Debian Linux. You can see, you can use the traditional PS command. It's a process list with the proper option. You can see some, not sure whether you can see the indent. That means it's a child process of this one. And this, I learned the PS command, right? PS command is most inside, which means it's a child, the youngest process, whose process ID is 2399. Okay, its parent process is 2199. Who executed this one? My shell program. In this case, own shell program. Own shell is here 2199. Okay, this one is actually executed by 2199. So parent. Let me see. It's not parent ID. Yeah, there's no parent ID here. Its parent is this one. Okay. Then This one, parent of this one is the genome terminal. That is the interface program. So then this one is executed by init process. Okay, which means in other words, first init process is started. The init process start the interface program. That is the genome, and genome. When you log on, when I log on, the bash shell is started, and then bash shell execute the ps command, something like that. Whenever you create the process, actually the system code, fork and exe are executed. Also, you can use something program like the PS3. It's much easier to very close. Okay, so you can see such a process tree from init. You can see the init process. That init process is a lot of system process. Then mine is, where's mine? Oh, PS3 is executed by, created by the shell and created by the genome interface. Then that one is created by init process. This is the same thing in the Windows. Oh yes, I have. So you can see this is a command to browse the list of the process. Also, we can use the parent process ID, and the parent process ID is not described here. We can. I'm not sure. PS list. There might be 3. Which one is the 3? Oh yes, -T option. So you can see, for example, this VMware started by the VM player. VM player is started by the, what is the first one? The win init. You can see the win init, that is the init process, kernel process of the Windows system. Okay. Then that's how to create the process. Then once the job is done, should be ended. The ending of the process is called the termination. So termination, there are different situation when you need to terminate the process. Okay. So for example, when the parent process, okay, need to terminate the stop the children process forcefully, like for example Control-C, okay, or the close the window, the program that you execute. That is called abort. Okay, abort means it's not done in your programming code. It's stopped by your parent process. Okay, that is called abort. Okay. Then at the time, so you need to return all the results, then inform to your parent process. Okay. Also, the problem is when parent process is active, which means I'd like to log out. But what if the process that I created, at that time, there are several options. Mostly, it's a cascade terminating, which means the whole child process will be aborted. automatically. Which means when you log out, when you exit your current process, then inform to your parent process, your child process. In other words, the process you create will be automatically terminated, exit. So aborted. Abort is a little bit different from the terminate. The terminate means it's a normal, gracefully exit. Abort is forcefully exit. Okay? So that is called all the children process will be terminated. That is a cascading termination. So exit and abort are different. So exit is the gracefully the terminate, and why the abort means it's the forcefully exit. But both of them, the return all your resource and inform to your parent process. Okay. Definitely, all the open files should be closed. Then you release the lock for the file, then the other process can access it, and all the resources will be free. There are different levels of exit. Okay, so for example, in Linux system, by the way, what is the best way to find the information about the Unix command or Linux command? It's the man. Okay? If you know the man command, you can do everything. Man stands for manual. Okay? So for example, I do not MAN. So for example, I'd like to know about how to terminate the process in Unix. So that is actually the kill command. So if you type the man here, it shows it has a different level of the signal. Okay, so usually 0 to 15. So you can see the details of such a kill level. Kill minus U means so kill all the process, then return all the resource. Okay? Something like that. In Linux, no. This is a kill command with when you know the process ID. However, you cannot kill the other process, which is not the child process. Only you can kill the child process. Okay? Then when you terminate, like this one, when you get such a kill signal, it's terminated, you execute the exit command. That means you inform you are going to exit and release the whole resource to your parent process. Then parent process wait for the response. Then it will be resumed after terminated. At this time, the problem is, what if parent is exit without notification to your child process? For example, you are running several programs like the Chrome and browser, and also you open some ticker program, watch the current news, something like that. Then what if you log out your interface? Can you see the same program once you log in your desktop again? It's automatically closed. However, MacBook actually asks you, right, whether you want to keep. That doesn't mean it's keep running. No, it just has the program name. Then when you log on again, it will execute again. So when you exit without notification to the child process, so child process should be automatically terminated. That is called the cascading. Then when the child process is cascading the termination, first time it will be zombie process. So zombie process means there's no parent's process ID. Instead, because he is my child process, so I create him. Then, however, without the terminating the child process, I'm terminated. Okay? At the time, he lose the parent relationship. Then, at that time, so my ID is 10, his ID is the 20. So his parent's ID is 10. However, because I am terminated, he does not have parents, which means it's a zombie process. Okay? Then, at that time, the init process take over the job as a parents.
Is it called orphan process?
Then, that is a zombie process after that. So, this time, so no parent is wait. So at the moment, it's a zombie process. Then it's a exit. Okay. However, sometimes still remain that process. Normally after zombie process, the init process kill this process. Okay. Then no more zombie process. Sometimes, not always, that zombie process is killed or terminated first. Then this process will be open process. Okay? So, however, even though actually that is true, when you normally, I've done my job, so I'm going to terminate. Then you inform to your parent process. Even that time, it's a slightly, at the moment, so very short time, you will be zombie process. Then actually operating system, take care everything. So slightly, at the slight moment, it will be zombie. But if that is not the completed, so process exists, but so there is no parent process. Okay? Then that is open process.
So you're saying every process with the parent process is terminated without informing the child process?
Yes.
So for momentarily.
Yes, it's going to be a little bit zombie. Then the init process will take care. Okay, as a operating system. Then it will be the terminated firstly. Okay, so aborted.
So the child process will automatically be terminated.
Yes. Okay, that is the cascade actually terminated.
So in that case, it will be called orphan.
Then, if still remains as a process without parent process, okay, that is called the open process. Sometimes somebody said this open process as a zombie process also. Okay, because there is no parent, but it's still the process. Then the problem is you can find many processes whose parent ID is 1. Some of them are not system process. Okay? Some of them are not system process. Many of them are system process, which means when the operating system starts up, init process starts this. However, some of them are not real system process. However, we are not going to call such a process as the open process or zombie process. That is called daemon process. So you heard about the daemon process. Daemon process, actually, I create, for example, web server as a service. So web service. So you probably learned about the client server environment in TCP/IP, the protocol. So we can create the web server. Okay, then web server is listening the request of the client from the client. Then the specific HTML file will be returned, something like that. That is client server and in the TCP/IP environment. So I try to run the web server. Okay, so I start the web server. For example, that is a HTTP. Then my this process ID is 20, parent ID is 10. I cannot log on forever because I wanna return to home. So I log on. What happened? Web server will be, this process will be terminated. But you don't want to do that. At that time, you can change parent relationship into one. Okay? Which means even though you log out, this child process will not be terminated and still working for the service as a server. That is called daemon program. That's part of the open program process, but it's different from the typical open program. Is called the daemon program. Usually daemon program is a service program. Okay? After you execute it, there is a you can separate such a relationship as a daemon program. For example, background. Okay? Background program is kind of such an example of the daemon program. So it's a good question actually. I heard some of the people when they have the interview, what is different between daemon and the zombie process, or daemon and the open process? The daemon is intentionally you leave the process, or you disconnect the parental relationship and give the permission of that process to the init process, operating system, for the service. Also, when you create the process, when you execute the process in operating system, sometimes several processes works together. Okay, for example, this is an example of the Chrome. Okay, when you run the Google Chrome browser, there's long time ago browser has only one process. But if you check the task manager, you can see a lot of the Chrome. Sometimes it's annoying. However, there's basically 3 processes are running together. One of them is, for example, plugin, or another one is manage the interface of the Chrome itself, and render is for something JavaScript or HTML5 rendering and something like that. So several processes are running together. Okay, so which means we need to communicate between or among the process. That is called inter-process communication. Some of them are, even though we create the several children processes independent, but most of them, they are cooperating processes, which means they need to work together. They need to communicate it. Okay? The reason for that cooperating process, you need to share the information. Also, you can scale up, you can speed up by running the several multiple processes. Okay? And also, in your program, intentionally, you can create the several children processes. This is the first process working for the reading data. Second is the receiving the data, and third one is the checking the error, and something like that is the modularity, and also convenience. How can we communicate? There are mainly 2 types of the communication. One is using memory, shared memory. For example, for our communication, I'd like to put the bulletin board over here. So I can put the note over here, then student can check here, then some of the student do not like such the notification and put another note. So we can communicate with shared area. Okay, that's one way. Similarly, we can use the shared memory. We can allocate the specific area on the memory and give the permission. Otherwise, the process cannot access a specific segment. So once you give the permission to access it, which is accessed by other, then the other process can check the data, shared data. That is the shared memory, the approach for communication. The second part is a message passing. So we are going to create something communication method between he and me. Like I connect the string. When I was the elementary school, I used the CAN, two CAN, and connect the string so we can communicate. It's a dedicated. It's the same thing. No matter what method you use, you can create the communication method. So message passing can be implemented many different ways. You can use existing hardware or instruction, the software-based the data structure, such as message queue. You know the queue is data structure, first in, first out. Okay. Also, you can use network protocol, network method. So if you take the network course, so you probably learn OSI 7 layer. Do you remember that?
Mhm.
Or you remember? I forgot, right? Or after the final exam. But it has something layer, and TCP/IP layer, then application layer, something like that. We can use such a network protocol also for the communication. One of the example is the socket program. Socket program. This is one of the examples, and very popular nowadays, even for remote. Even inside the computers, the same computer, intercommunication, we can use socket method. Okay, socket is why it's popular, because it's based on the client server, the architecture. Server is the process provide the service, and client is the request, like the web service. Web service is one of the typical example of the client server environment, and socket is one of the methods. These are the one of the example of the message passing. Go back to your warming up project. What is the goal of the warming up project? Warming up. So you need to implement CH3 paper of two-child process. So basically you need to create your own program. From your main function, you need to create a two-child program using system code that we learned. Very easy for EXEC. For EXEC part, you need to assign specific code to generate seizure or lock or paper, one of three. You don't have to try to create the real seizure lock paper, just a 0 or 1 or 2. That's it. That's pretty much enough. Okay? One of the random number from each. So each child process is exactly the same code. You don't have to create the separately. It's the same code, but when you assign the EXEC code, you can do the two time and communicate. How to communicate? You can use any of this. We will see a little bit more. However, this is not the network programming class, or this is not the Unix programming class. We are not going to discuss details how to do that, but we will see roughly. So you can select one of them, but I recommend to use the socket program. That is one of the easy, and because the warming up project is not the main part, so it's not competition of your programming skill. So to give you, my student, to understand the basic mechanism of the creating process and the understanding the communication. So this part is up to you. You can use the socket, or you can use the message queue. You can allocate the data structure for the message queue and send the message. What kind of message? 0 or 1 or 2 from child to the main function, and main function decide who is the winner and return. Then each process will send the data. That's it. Very simple. However, if you are using C or C++ program under the Windows or Linux, you can use the fork and EXEC system code directly. Or if you are using the Windows API, you can use the create process and with the proper the parameter and also the communication method, no problem. However, nowadays it's getting higher level, which means abstract, hide inside, right? So for example, Java does not use directly fork and exec system code. There exists a library who pretend such a thing, but that's kind of some educational purpose or the specific purpose. It's exactly the same. So in Java, if you want to use the Java, you need to actually create the command in different virtual machine. Okay? Because in Java, due to the nature of the Java, if you actually create a process within the same virtual machine, it's not the process, it's a thread. Okay? It's a separate the object file. Because the Java virtual machine is one process, and that create inside that, so you create the thread. So which is too easy. You can use even the global, the variable for communication, right? So if you want to use such a virtual machine base, right? So you need to, when you create the process, when you create the child process, create the separate virtual machine. Okay? Then you will be assigned, each virtual machine will be assigned the new process ID. Then establish any communication method. Okay? So you need to implement the main function, then inside that, then call another program as a separate the virtual machine. It's the same thing nowadays, too many different programming interface which I don't know much, but that should be separate. Okay? Any question regarding to the warming up project? If you are familiar with the basic programming, including the network programming, it takes 30 minutes, I believe. Okay, less than 30 minutes. And number of code is, I don't want very fancy, nice the graphical user interface. If you want, you can do that, but it's not required. Okay, that's not main purpose. I know, but if you are using C# or the Visual Studio interface, the IDE, you pretty much start from the Windows, so you still want too much the graphical user interface, but it's up to you. But you do not get the extra credit, even though you implement a very fancy, nice. Some of the students try to use the feature that represent 0, 1, 2, okay? But it's up to you. But main part, the main purpose of this warming up, that's the reason it's a warming up project, is the understanding in your programming language how to create, how to handle the child process, and also how to establish the communication method. I used this warming up project almost every semester whenever I offer. So far, one student used the shared memory, okay, for the communication. So not easy, but even though challenging, so you can try. And some of the students used a message queue, which is not very difficult. You already did in your data structure course to create the message and allocate the message to them and pick up the message. So that can be another method. So, and depending on the hardware, so some of the you can find the instruction for the communication, so you can use that. Otherwise, if you are not familiar, I recommend to use the socket program. You can find a bunch of reference for the socket program in any program language. Okay? In any program language, you can find some reference program. Any question? So it's an individual project, okay? But if you refer any existing code, that's doable. Sometimes I don't know anything, so I try to use existing code, but the change that fit to the objective. But at that time, you need to provide a proper citation. Okay? Without citation, it will be considered as the plagiarism, so it will be automatically done fail. Okay? Also, sometimes one of the benefits of too many students is sometimes easily find 2 or 3 duplicated submission. Okay, they don't discuss it ever, but they copy it from the same. Okay, and also don't even think about to use the website that post kind of a bidding system for your project. What? It's kind of bidding system, auction. Yeah, so you can put the project description to that website. Some of the skillful and then the powerful, the developer, it's a $10, $20, something like that. Because there are professors who watch that kind of whether school project is bidding or not. Okay, so last semester one of the students actually was caught, but in her case she was not on purpose. Okay, so she didn't know. So she was a new student to here, so it was okay. But especially for graduate student, so if I quote anything like that, catch anything like that, it's automatically fail. So it's just for your practice, please. Okay, it doesn't take a long time. I'm not very good programmer and very skillful, but I want for computer science student to code any algorithm or project. Okay, otherwise there's no way. So if you are